I want to introduce you, if you haven't met, dimensional analysis. This is a technique for solving problems using units as your guide. It's also called unit analysis. Dimensions are referring to the units. You should always include units in your calculations. They are part of the measurement. Go to McDonald's and say, I want 5. Are they going to understand what you mean? No. They don't know if you're asking for 5 of something or if you want the number 5 meal. You have to tell them 5 what. It's really important to always include your units, okay? When we write them out, they can be multiplied, divided, canceled out, just like algebra variables. X times x is x squared. Meters times meters is meters squared. They can cancel each other out. So dimensional analysis, we use the units to help us know what to do with the numbers. And it works for a lot of the problems we do. Of course, the original place it's useful for is converting units from one to another. So we're going to start with a simple one, relating inches and centimeters. So this is the relationship between inches and centimeters. This is one you should memorize. 2.54 centimeters equals 1 inch. We can make a conversion factor out of this. So 2.54 centimeters is equal to 1 inch. So let's say I decide I'm going to divide both sides by 1 inch. If I do the same thing to both sides of an equation, it is still equal, right? Now I look at what I've got over here. 1 over 1 is just 1. And inch over inch is just 1. And so this is numerically equal to 1. Okay with that? I could also come up with 1 inch over 2.54 centimeters and show you that that is also equal to 1. This is what is called a conversion factor. It's a relationship between the units, one over the other, that's equal to 1. What happens when I multiply a number by 1? It's the same number. Right? I can multiply a number by this conversion factor and not change the quantity. So usually these are going to have a form like this. You're given information, a given unit. There's information that you're trying to find out, the desired unit. And what you're going to do is you're going to apply a conversion factor where the desired unit is on top and the given unit is on the bottom. The given unit cancels out, leaving you with the desired unit. Okay, so let's do this one. How many centimeters are in 12 inches? So this is the given quantity, and this is what they're asking us about. So they're giving us 12 inches, and they're asking us to convert that to centimeters. So I'm going to start out with 12 inches, and I'm trying to get to centimeters, so I want to multiply by centimeters. And then I'm going to divide by inches. Because then inches divided by inches, and poof, the inches go away. But a centimeter is not equal to 1 inch. 1 inch equals how many centimeters? 2.54. Does 1 centimeter equal 2.54 inches? No. We have to get the number with its unit. So what's on the top of the conversion factor is numerically equal to what's on the bottom. They are the same distance, they just have different names. So then we multiply. We have 12 times 2.54. And my calculator says 30.48. And the unit is going to be centimeters. We do have to think about significant figures. Is this relationship exact? Yes, it is. It's one of the weird ones that is exact. When the relationship is exact, I just don't even need to think about it. I look at everything else for sig figs. How many significant figures does 12 inches have? 2. It's not an exact number. It's not a counting number. So that has 2 significant figures, so then my answer should have 2. So here, if I'm going to write 30, and I intend that that 0 be a significant figure, I'd have to put a decimal point there, which is kind of weird, huh? It'd be better to put that in scientific notation, 3.0 times 10 to the 1 centimeters. Any questions? So general problem solving, many students struggle with these word problems or story problems. If you're one of those people, I find that there's 2 kinds of people. There's people who get story problems and people who don't. And it has no correlation with intelligence. It has to do with how your brain works. There are people that can read a short story and immediately pick out the theme of the story and who the protagonist is. I don't get stuff like that. But if you don't get story problems, you're probably better at things like that. So we just have different strengths. But you can learn how to do story problems, and if you want to be successful in here, you're going to have to. So ask me if you need help. Identify the starting point. Where are you? Then figure out where you're trying to go. This is a lot like navigating the Stanford Mall. You know, you want to get to Starbucks. I had this happen last spring. You want to get to Starbucks, and so you're like, I don't know where it is. This place is really confusing. So you find a map on one of those little kiosk things, and there's that red dot that says you are here, right? So that's the first part, is you have to figure out where you're starting. Then you have to find Starbucks. That's where I'm trying to go. And then you figure out, how do I get from here to there? If you don't know where you are, or you don't know where you're going, you can't figure out how to get there. So those are the same things we do here. Another way to think of it is sort, strategize, solve, and check. Okay, so using metric prefixes. 1 kilometer equals how many meters? 1,000. Kilo stands for 10 to the 3. So you could write 1,000 in here. I'd encourage you, though, to use the powers of 10. It sounds almost mystical, doesn't it? Use the power of the 4s. So kilo means 10 to the 3. If you haven't started memorizing those, you need to. There's a quiz on Wednesday. 10 to the 3 is the same as 1 times 10 to the 3, right? So now this is a number that you can enter into your calculator, and you would do that as 1, then the EE button, and 3 for the exponent. Or you may have a button that says EXP. Make sure during lab today that you understand how your calculator works, because a lot of students muddled through Chem 3A without really getting how to talk to their calculator. This is important. The prefix goes on one side of the equal sign, and the multiplier on the other side. Now, when we use a smaller prefix, like if we're saying 1 centigram equals how many grams, what does centi mean? 10 to the minus 2. Is there another way you can express that? Yeah. You could say that there are 100 centigrams in 1 gram. That is true. And if this stuff makes sense to you, you'll be fine doing that. If you find unit conversions confusing, don't do that. Follow this pattern. The prefix on one side, the power of 10 on the other, always, always, it works every single time. Just follow the pattern, okay? What if you're converting units And both of them have prefixes. So let's say we're doing, well, there's the example right there. Centimeters to nanometers. Could you do it in one step? You could. I do this for a living, and I would really have to stop and figure out what to do there. It's perilous. Don't go there. Just do it in 2 steps. So look at it this way. If you are converting units and one of them has a prefix and one doesn't, it's 1 step. If you're converting units and 2 of them have prefixes, both of them, then it's 2 steps. 2 prefixes, 2 steps. Your middle step is going to the base unit without the prefix. So to do centimeters to nanometers, you're going to do centimeters to meters first, and then meters to nanometers. Because we can use this pattern to write the conversion factors for centimeter to meter and meter to nanometer. You can't magically use the prefixes and go centimeters to nanometers. It's messy and dangerous. So give me a number. 6. That's not a very interesting number. Let's make it 6.94. I don't know. Centimeters. And we're going to convert to nanometers. So that's where I am. This is where I'm trying to go, and I have to figure out how to get there. Sometimes you can do it in 1 step, but here I've got 2 prefixes. I need 2 steps. So this is my path, my route, or route, depending on which part of the country you're from. For each arrow in this path, I'm going to have 1 conversion factor, 1 fraction. So I have 2 arrows. I'm going to have 2 fractions here. The units in this path are the units that are going to be on the top of all of those fractions. I'm starting with centimeters. So centimeters to meters, come on, meters to nanometers. Centimeters to meters to nanometers. I want to get rid of this unit, so I divide. I want to get rid of meters, so I divide. Unit analysis or dimensional analysis, I put the units in first, and then that tells me where to put the numbers. A lot less thinking this way. Relationship between meters and centimeters. Centis on the bottom, I'm going to write what centi means on the other side. Not with centi, on the other side. So centi means 10 to the minus 2. Here I've got nanometers and meters. Nano means 10 to the minus 9. I'm not going to put that with the nano. I'm going to put it on the other side. 10 to the minus 9. So use 10 to the something and never put it next to the prefix. You'll learn the pattern and it's easy peasy. So how do you do this in your calculator? Well, 10 to the minus 2 is the same as 1 times 10 to the minus 2. 10 to the minus 9 is the same as 1 times 10 to the minus 9. So you just enter them as scientific notation. So I'm doing 6.94 times 1 EE. That EE button stands for times 10 to the. On my calculator, when I press the EE button, it only shows me 1 E. That's fine. That's its own little shorthand. So I press the EE for times 10 to the, and then I put negative 2. And then I'm going to divide by 1 EE negative 9 equals. And I get this big old number. Most calculators have a way that you can convert between scientific and decimal notation without having to think about it. So it would be better to write this 6.94 times 10 to the 7th nanometers. These metric conversions are exact, so I don't have to think about sig figs. I started with 3, I end with 3. Done. Any questions? Convert centimeters to yards. So I identify where I am. I'm at 288 centimeters. Where do I want to go? Ultimately, my final destination, yards. So I'm at centimeters. I want to go to yards. Then I said, well, where do I have to stop in between? She said inches. That's correct. Because I can go from centimeters to inches. That's a relationship you should have memorized. Now, from inches to yards, some people might go inches to feet and feet to yards. Other people might say, well, I know there's 36 inches in a yard, so I'm going to go straight from inches to yards. Both of them are fine. Which one do you want to do? Feet or no feet? No feet. For every arrow, you have to know the relationship between those two things. So there's my path. And finding the path is generally the hardest part of a dimensional analysis problem. After that, it's just follow the pattern. 2 arrows, 2 fractions, centimeters to inches to yards. I put centimeters down here, so they cancel out. I put inches down here, so they cancel out. All my units are fine. Then I look at the relationships. Here I'm not using metric prefixes. Let's maybe do this one first because it seems easier. Yards and inches, what's the relationship? 1 yard is 36 inches. So 1 yard equals 36 inches. What's on the top has to equal what's on the bottom. That's what makes this equivalent to 1 and doesn't cause us to be changing this length. We're just changing the unit. Inches and centimeters. 1 inch equals 2.54 centimeters. Sometimes this is upside down. When we have centimeters on top, the 2.54 is still with the centimeter. So you got all the numbers in place. Then to do the math, the simplest thing is to just go left to right, top and bottom. So I'm going to start here, 288, times the top, divide by the bottom, times the top, divide by the bottom. Then you don't have to write down intermediate values, and it's way less confusing. So you get to this and you're like, times 1, that's not going to do anything. Do I have to punch that into my calculator? No, you don't. But for some people, it makes them feel better. If you want to do it, that's fine. Nobody's going to watch. So 288 times 1 divided by 2.54 times 1 divided by 36. And my calculator's giving me a whole bunch of digits, and so I'm thinking, I don't want to write down all of them. But Mrs. K said I shouldn't just round everything right away. So before you record this, think about the sig figs. Here's just multiplying and dividing. How many sig figs in 288 centimeters? 3. How about this one?
3.
It's exact. Inches and centimeters is exact. Trick check. How about this one? It's exact. Inches and yards are our English system. That's exact. So both of these are exact conversions. So if this has 3 sig figs, then this one has 3 sig figs. So what I would like you to get in the habit of doing is write down the correct number of sig figs. So I've got 3.14. That's the 3 sig figs. And then write down the next 2 digits that your calculator shows you, whatever they are. So it's showing me 96 yards. Then round it. So that is my result. This is helpful because what if I rounded it wrong? Or I miscounted sig figs or something, or maybe I need to use this number in a calculation and I didn't realize it. Now I have the unrounded version, enough of it anyway, that I don't have to do the calculation over again. So it's a good habit. Any questions? Sometimes we have to convert units that are raised to a power, either squared or cubed. When we do this, what we should do is look at the conversion factor for the regular unit, and then if it's squared, square the conversion factor. If it's cubed, cube the conversion factor. So if we're trying to do square inches to square centimeters, we need a relationship between square inches and square centimeters. But we don't know what that is off the top of our heads. But we do know that 1 inch is 2.54 centimeters. So 2.54 centimeters equals 1 inch. If I square both sides, it's still equal. So I square this and I square that. That squares the unit and it squares the number. So 1 inch, the quantity squared, is 1 squared inch squared, which is just 1 inch squared, right? But the quantity 2.54 centimeters squared is 2.54 squared centimeters squared, which is 6.45 square centimeters. So a square inch is 6.45 square centimeters. The common mistake is students forget to square the number or cube the number. So let's run through this one. This is similar to the one we just did with centimeters and yards, but we're going backwards and they're cubed. So we're going from cubic yards to cubic centimeters. So first off, ignore the threes. If I was doing yards to centimeters, I could do the reverse of what we did in that last problem. I could go yards to inches to centimeters, right? Because I know those relationships. So then put the cube in here, and you can do the same thing. So I've got 2 arrows. I have 2 conversion factors. Right now I'm leaving off the 3, and I'm just looking at, I'm going yards to inches to centimeters, and I'm going to get all my units in here so they work out. Got yards over yards, inches over inches. I'm getting a little sloppy. My inches kind of look like my centimeters. That's not very nice. What are the relationships? Well, we already established that. 36 inches is 1 yard. 2.54 centimeters is 1 inch. But this is yards cubed. So this conversion factor has to be cubed, and this conversion factor has to be cubed. When I do that, it cubes all the units inside and all the numbers inside. So you should write this down. This is called showing your work, and it's a big deal. Show your work. Many people can just run that straight through in their calculator and be fine. But I just want to expand on this a little bit and make sure that you understand what this is meaning. This is the same as 36 inches cubed over 1 yard cubed, which is 36 cubed inches cubed over 1 cubed yard cubed. Okay. And if you take that a step farther, 36 cubed is a big number. So you can't just multiply by 36. You're going to end up with the wrong number. It's 36 cubed. I think what messes people up is one side of this has the number 1 on it. And when you cube or square that, it doesn't change anything. And so then we get kind of complacent and we think that nothing changes. So on your calculator, you should have a way to cube things. So you have to figure out how your calculator works for that. So I'm going to do 2.11. Does this exponent on the yards affect the number? No. This exponent is only on the unit. Does this exponent affect the number? Yeah, because it's outside parentheses that are including everything. So it affects everything inside. 2.11 cubic yards, only yard is cubed, not the 2.11. So 2.11 times 36 to the third power times 2.54 to the third power, and I get a really messy number. How's that for messy? I don't like writing down that many digits. How many significant figures should that answer have? 3. This is exact, this is exact. Starting number had 3, ending number should have 3. So is that 161 cubic centimeters? No. That's 1.6 million cubic centimeters. That's not the same as 161. So if you're going to round it like this, that's way bigger than the tens place. You look at the decider, it's smaller than 5. We're going to keep this as a 1. Replace all of these digits before the decimal point with a 0. There's 4 of them, so I need 4 zeros. So that's an acceptable answer. The safer thing, put this into scientific notation. You can round it as you're doing that. So if I'm going to put that in scientific notation, I've got a non-zero digit and a decimal point, and then however many things I want to keep after that. What? I don't know what's going on there. So 1.61, there's my 3 significant figures. I look at the next one, it's less than 5. I don't have to change the 1. Done. I'm stopping there at times 10. And that exponent, remember, is how many places I'm moving the decimal point. So I'm putting the decimal point here. 1, 2, 3, 4, 5, 6. I'm moving it 6 places. Is it a positive 6 or negative 6? It's a positive 6, because this is a stinking big number. I'd be thrilled if that was my paycheck, especially for a month. That'd be awesome. Of course, it'd probably be pennies or something. So this is the best answer. This answer is okay. Question you might be thinking is, when should I put it in scientific notation? Unless the problem says otherwise, I think scientific notation is never incorrect. Sometimes it looks a little weird, but it's never wrong. My feeling is, if I can't immediately see how many numbers, how many zeros there are, without getting out my finger and counting them, I should use scientific notation. I feel like a kindergartner when I have to count the digits, right? You just feel lame. But if I don't do that, I get them wrong because they start to swim together, right? So usually if there's like more than 3 zeros, scientific notation is easier to look at. That's all. Oh. You know, we could just go on and on and on. What do we have here? Let's use this one. Let's do this one. Backpackers often use canisters of white gas to fuel a cooking stove burner. If one canister contains 1.45 liters of white gas and the density of the gas is 0.710 grams per cubic centimeter, what is the mass of the fuel in kilograms? The first thing is to read the question all the way through, even if it doesn't make any sense. Read through. Then you go back and figure out, what are they asking me to find? Usually there's a question word. Here the question word is what? What is the mass in kilograms? So that's what I'm trying to find. So I'm trying to find kilograms. What am I starting with? So I have liters and I have grams per cubic centimeter. So they gave me two numbers. These other problems, we've only had one number. It's been easy to know what we're starting with. So this can be a little confusing. So look at these and look at the units. When you've got multiple things like this, look at the unit you're ending up with. This is a simple unit. It's not a derived unit. That's what the word is. It's just kilograms. So I look at these. This is a simple unit, just liters. This is a derived unit. It's got 2 units in it, grams per cubic centimeters, right? So most of the time, this is what you're going to start with. This is a conversion factor. It's a relationship between grams and cubic centimeters. I can't use this as a conversion factor. So that tells me I'm going to start with liters. So I've got where I am and where I'm going, and I have to figure out how to get there. Well, you're not going to find a relationship between liters and kilograms in a conversion table. We need to use what we've got. So we're probably supposed to use this somehow, right? Grams and cubic centimeters. Well, is either of these closely related to either the beginning or the ending? Yeah. Gram and kilogram, those look like they kind of go together. So let's put gram here. We know we can go from grams to kilograms. This density relationship gives us the conversion between grams and cubic centimeters. So we can put cubic centimeters here. Sometimes it's easier to work backwards. Sometimes you have to work from both ends and hope you meet in the middle. Yeah. Well, we can do that. So he pointed out that this is the same as a milliliter. And that's very important. So you can, I give you permission, anytime you see cubic centimeters, you are welcome to just cross that out and write milliliters instead. So here, milliliters. You can absolutely do that. Okay? Or you can have another step where you go milliliters to cubic centimeters. And so you'd have 4 fractions instead of 3. Whatever makes more sense. 1 cubic centimeter is exactly the same as a milliliter. So I'm going to do it the long way. Four arrows, 4 lines, liters to milliliters. I'm just reading off the path I wrote down. Milliliters to cubic centimeters, to grams, to kilograms. I divide by the previous unit. I've got grams here, and I divide by grams, so those cancel out. And these cancel out. And these cancel out. And those cancel out. All the units. just following a pattern. Then I need the relationships. So here, milliliters to liters. One prefix, no prefix. Milli means 10 to the minus 3. I write that on the other side of the line. That's 1 times 10 to the minus 3. What's this relationship? 1 over 1. And you might think, oh, duh, I could have skipped that. Well, yeah, we could have, but it doesn't hurt to put it in. What's this one? 0.710. That's a conversion factor that is specific to this situation. That's not always true, but it's true for this white gas. So the 0.710 goes with gram per cubic centimeter. Now, some people are disturbed that there's no number down there. Well, you can put the number 1 if that makes you feel better. It's fine. And then here are kilograms and grams. What does kilo stand for? 10 to the 3. So I've got kilo on top. I want to put kilo on the other side. I want to put 10 to the 3 on the other side. I don't want kilo and 10 to the 3 together. So 1 kilogram is 1 times 10 to the 3rd grams. .45 divided by 1 EE minus 3 times 1 divided by 1 times 0.710 divided by 1 EE3 equals. How many significant figures should my answer have? 3. My starting number had 3. Exact. This one's not exact. It has 3. So I'm thinking about 3 sig figs as I'm writing this down. Copying what my calculator says. I get to the 3rd digit, I underline it. And then I write down 2 more, which happens to be all of them. Then I look at it again and round it, and it rounds to 1.03 kilograms. So this is using density as a conversion factor. It is possible to use the density equation in algebra and rearrange it, but I see students doing all kinds of crazy, stupid things with that. Please don't. Use it as a conversion factor. The first couple of times you're like, oh, I'm not sure what I'm doing. Once you see it, it's so much faster than doing algebra, rearranging the equation. Because what happens with the fractions and the equations, students end up with things upside down and backwards, and they get the wrong answer. Density is a conversion factor. The only time you need the density equation is when you're calculating the density. So that's another example. I don't want to talk about that. There's never time for that. Sometimes you have equations. Sometimes you have to use an equation. You might have to use algebra. An example is something like this, where you have the volume of a cylinder. The volume is pi r squared times the length of the cylinder. They're giving you the length of the cylinder and the mass, and they're asking you for the radius. I think we're all done listening to me talk, so I'm not going to do the whole thing here. I'm pretty sure I have it as a video on YouTube somewhere. I'll find it and pull it into your playlist. So you're trying to find the radius, and you've got this other information. This is one that you're going to have to apply a little critical thinking to. So you've got this equation. So you want R, so you could rearrange the equation, solve for R, but then you need the volume and the length. Well, that's okay, you have the length here, but they give you the mass. How do you get the volume from a mass? Density. Density relates mass and volume. They're telling us it's aluminum. we can go to the density table and look up the density of aluminum. From the mass, we can find the volume, plug it into the equation. There's the density. Yeah. Call it a day.